Hello everyone and welcome to this new and exciting session. In this session, we shall be building a system which permits us automatically detect whether an input, which in this case is an image, is that of an angry, happy, or a sad person. So this person may be sad, as you could see here. The person may be angry, as you could see here, or the person may be happy. So in fact, we want to be able to have this kind of input, pass it into our system which we want to build, and then automatically infer that this is a happy person. And so to train the system, we'll be making use of this data set which has been made available to us by Muhammad Hanan Asgar. And since this data set is available on Kaggle, just anyone could have access to it. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. We are now going to take a closer look at this data set. As you could see here, we have this test and train directories. You open up the train, open up the test. You see you have these three different folders: angry, happy, sad. Here for the train, you have angry, happy, sad too. So what we do is, generally, when trying to create this kinds of data set for classification problems, what you want to do is make sure that you put the different images in separate directories. So all images representing angry people are in this directory, happy in this directory, and sad in this directory. Now this way it becomes easy for us to build our model taking this data set as input. Also, in the previous sessions, we explained the reason why it's very important for us to split our data set in this kind of manner, such that while you use part of the data set, that's the training, to actually train or build your model, you're going to use the other part to evaluate this model. So although in this case, we've just been given this data, which is very unlike what you have in real world scenarios where you will be asked or tasked to build your own data set like this. One very important thing you have to note is the fact that if, for example, you're building this kind of data set where, say, we want to monitor the usage of an app, or better still, monitor how the users of an app react to a certain feature, then it's important to gather data that reflects or is very similar to what the data, or rather what the model will be seeing during inference. And so this means that if you have this kind of data, or if your model is going to be seeing this kind of data during the inference, or when it's going to make use of the model to predict whether there's a happy image or not, then training on this kind of data isn't a good idea, although this is images, or these are images of happy people. So you have to ensure that the data you train on is representative of the data or the kinds of inputs the model will be seeing when it's going to be deployed and left to predict or make predictions from these kinds of images. Then, if you have noticed, not all classes we have here have the same number of files. So here you have for happy 1000, angry 500, sad 757. For the train is 1525, here 3000, sad 2255. So this shows us that when solving your real world problems, it may happen that some class, or it's easier to gather data from a particular class as compared to the other. So here, maybe the author of this data set found it easier to gather happy images as compared to angry images. Another very important point to note here is the fact that the kind of problem we're trying to solve is that of multi-class classification. So unlike previously where we had a model, we had some data which when passed in, we would say whether this is a parasitic or non-parasitic input cell. Whereas here, what our model outputs isn't just either one class or the other, but a model which outputs a given class out of several options. Now those options could be 3, 4, 5, 6, 7, or even 1,000 different possibilities. Now all those different possibilities are termed classes. So in this case, we have 3 classes. The first class is that of the angry person. The next class, happy person. The other class, a sad person. Now to be able to download this data, the very first thing we want to do is create this new API token right here. So you get to your profile, you click on account, and you have this here. Click here and save this kaggle.json file. So we'll get that saved. Then getting back to the Colab notebook, we'll simply copy this in here. Okay. And then we should have this here. Now before moving on, it's important to note that you will have to sign up for a Kaggle account. And then the next step will be to install this Kaggle package. So pip install Kaggle, run that cell. Then we create this directory. So we make this directory, and then we copy this JSON file in this directory. So again, we run this cell. Then from here, we give the user full rights to read and write into this Kaggle file right here. We run the cell, then get back to Kaggle where we are going to copy this API command. Now, after copying this API command, we're going to paste this just here. So here we have Kaggle datasets download. So we're going to download this dataset, this human emotions dataset. Let's run the cell. Our dataset has been downloaded. Now we're left to unzip this downloaded file. Let's click this here. You see we have human emotions dataset.zip. We now unzip this and store in this dataset folder. So you're going to run the cell. You'll see that it's going to create this folder dataset, and in this dataset you have the emotions dataset which we saw in Kaggle. Basically, this is the dataset right here. From this point, we'll go on to generate a TensorFlow dataset based off the images which are found in the directories. So we're going to make use of this image dataset from directory method, which is in the Keras utils package right here. So here we have this description. See here we have this different arguments directory. Now the directory, let's copy this so we see clearly this in the code. We copy and paste this out here. This directory is going to be simply one of these directories here. So here, first thing we'll do is we'll create our train data set. So that's our train data set, which is a TensorFlow data set. We've seen this already. We're going to specify the directory. So let's call this train directory, and we'll simply copy this path. So let's copy this path and then paste it out here. Copy that path, paste it. Now we have our validation directory. We're gonna do the same thing. So basically, again, we're gonna copy this here, copy here, and paste. Now here we're gonna use this as our train data set, and we're gonna use this as our validation data set. So here's our train, here's our validation, and that's it. So with this, let's run this cell. That's it. We get back here, we change this to train directory. Now here the labels are inferred, and this means that the labels will be generated from the directory structure. So if you could look at this here, this example, you have this main directory and you have the directory structure. That's why at the beginning we made mention of the fact that it's important to maintain this kind of directory structure when dealing with classification problems. So because we have this kind of directory structure where we have a class, we have its images, we have another class, and then its images, like we could see here, we have this in the train, we have the class, we have the images, we have this class and its images, this class and its images. We are able to automatically create this kind of data set. And that's the role of this inferred right here. Then the next one we have is a label mode. Now for the label mode, we have several modes. Here the default, we have the int, we have categorical, we have binary or none. Now let's explain what these different modes mean. For the integer mode, we're simply meaning that when we design, or the way we design our data set is such that we have an image and we have a label. So let's say we have this image of this person, the person is happy, and we have three different possibilities. Either the person is angry, happy, or sad. So here what we're gonna have is angry. We're gonna give it a value of 0, happy a value of 1, sad a value of 2. So here are three different possibilities. And so when designing this data set, or when creating this data set, we'll create it such that we have the image and this integer which reflects what that the emotion in that image. So here in our case, in the case of happy, we would simply have an output of 1. Now that said, either we create our data set in this way, or we use a one-hot representation of these labels. So what this means is, instead of having a 0, we'll create a vector of size 3, which has 3 different positions, where if we have an angry input, so if the person is angry, we'll put a 1 on this position and 0, 0 here. If the person is happy, we'll put a 0 here, a 1 and a 0. And if the person is sad, we'll put a 0 here, a 0 and a 1. And the way this encoding works is that where we have a 0, you see the position is 1 for the one hot representation. Where we have a 1 happy person, we put a 1 at the first position. Where we have a sad person, we put a 2. We have a 2, and so we put a 1 at the second position. And then with this, there'll be some differences in the designing of the loss function, which we are going to see in subsequent sessions. Now we have this binary. For the binary is like the previous example or the previous project we worked in, where we have 2 classes. So where we have 2 classes, we just have the label mode to be binary. In our case, we may pick out the integer or the categorical. Then from here we have the class names. Now if you've decided to infer directly from the class directory, then it's important to make sure that those class names match the subdirectories. So you should ensure that if here, for example, you have these class names, let's put out the class names here. So here we would have class names, and let's say we want to have angry. We have angry, we have happy, we have sad. Okay, so here's our class names. Now if we don't put this exactly as it is here, we should have an error. So let's run this. We have class names there. We get back here, and instead of having this here, we're going to specify our class names. So here we have our class names. There we go. So we have that. The next is the color mode, RGB. The batch size by default is 32. The image size, here the default is 256 by 256. We could always modify this. Shuffling by default is true. So by default, we're going to shuffle our data set. So we do not need to explicitly do this shuffling. So we just have to specify this to be true, and that's done. Now for reproducibility, we could give a seed such that we always have the same shuffling. Then we have this validation split. So here in a case where, let's say we have just one directory, let's say we just have the dataset directory, we do not have this test, we may want to split this directory into the training and validation. So here we could have here, let's say 0.2, and automatically we're going to have a split of this dataset into the training and validation datasets. Now once you have the split, since you're creating the training data set, you specify that this is training. So training is actually in the documentation here. You have your validation split. It's an optional float between 0 and 1, which is logical since we're splitting our data set, and then we'll specify either training or validation. So let's get back here. So in this case, it will be training. The interpolation bilinear, follow links false, crop to aspect ratio false. So these are the default values. We're not gonna use this. Take this off. And in this case, or in the case where we would have had validation, we just have your validation. So anyway, we're not gonna use this. Let's take this off. That said, by default, the validation split is known. So optional float, we're not going to do any validation. So that said, let's have this off and let's run this and see what our data set, our trained data set is about. So here we have 6,799 files belonging to 3 classes. Now let's go ahead and modify this. Let's add that. This is that. Let's run this now and see what we get. You see already we have this error because there's no matching. The class names passed did not match the names of the subdirectories of the target directory. So I expected this, but instead received this. So let's get back, modify it here. There we go. That's fine. We run this here and that's fine. Okay, so that's our training data. We could do the same for our validation data. So validation, or let's say val, and your string. Okay, so your string, here's val, and we have the val directory. We have the val directory. Let's ensure that here we call this val directory. We get back, and that's it. Okay, here's invert, label mode int, class name, same class names, RGB 32, image size 256. Now let's change this and have configuration and batch size. Okay, so that's our batch size. Here we'll have this as image size. So im size, take this off, paste that out. We have here our im size. Okay, so we have this configurations, and then we could create this here configuration. There we go. We have the batch size, which will take a value of 32. We have the im size, which will take a value of 256. So we have that. Let's run this. We get back here this configurations. Let's copy this here, and that's fine. We have our 2,278 files belonging to 3 different classes for our validation data set. From here, we're gonna look at our data set. So let's say for D, or for image and label in val, or let's just say for I in val data set. Let's take one batch. We're gonna print out I. So run that. Scroll down, see we have the images. We're interested in looking at the labels for now, so let's go down, let's scroll up to this here. Okay, you see the labels, we have 2 2 0 0 1. You see the labeling is between 0 and 1 because we have 3 different classes. Now let's modify this. Instead of having the label mode to int, this is int already, or let's change it to categorical, and this here categorical. Run that, run this, and okay, so we'll see what we get. So here, instead of having two, what we have is this one hot representation here, where everywhere is 0 except at the second position. So here, instead of having a 0, we have everywhere 0 except at the 0th position. So that's it. Now we shall go on to visualize this data. So here we have this figure, and then we specify the figure size. So we have your fig size, and we have this. So let's say 12 by 12. Okay, so we have that. And then for images and labels in our trained data set, we have this in our trained data set. You could always change this and put, for example, the validation data set. So we have that in our trained data set. We take just one, then we create a subplot here, plt.subplot. It's gonna be 4 by 4, then I plus 1. Okay, so we have that, and then we'll do an im show. So we plot out the image, basically this image right here, and then we select a given image. So we have that, and then we divide all these pixels values by 255. So we have that, and then next step is to plot out the title. So now we plot out the images, then we go ahead to plot out the different titles. Then here we have the outputs, that's the labels. Basically select the label, so we select the particular label just as we selected the image, and then we have, because the labels will be a one-hot representation, then we have to take the argmax. Now if you're new to this, you could check out the previous sessions where we talk about this kinds of methods here. So we have the argmax of this, and we have an axis. Let's specify this axis 0. That's fine. I think here we should also just do the plotting, so we should take off the axis, sorry, so axis and off. So let's run this so you see what we get before we have that. Anyway, here we have numpy, so let's convert this to numpy, run that again. You have this output, there we go. You see that we have the image and its class above. Now to convert this into some words, let's make use of the class names. So we have class names, and then here we have this. We run this again. We now get the different images and their labels. At this point, our data set is now ready for training. We just have to include this prefetching here for a more efficient usage of our data. We saw this kinds of prefetching, or we explained what prefetching was all about in some previous sessions. So here we have the prefetching. We're not going to include the batching because here already we've included a batch size previously. So in this data set loading right here, we specify the batch size. So our data is already batched. Now we have that. We run the solve for the training, and then we simply redo this for the validation. So this is our validation, data validation, and now we're ready for building our model. But before going on to build our model, we shall copy out this code here from the previous session and paste it out here. So we have this resize, rescale layers, which we're going to include in the model. Now recall that we could do this resizing, like we have our data set here. So supposing you have your data set, you could do the resizing and rescaling here. There's a rescaling and there's a resizing to the required size before passing this data into the model. So this could be done before passing into the model, such that you could train your model on this resized and rescaled data. Now another method will be to pass in your data here. So let's suppose that we have, let's take this off. We suppose that here we have, in this middle, we have the resizing and rescaling unit. So we resize and rescale before passing into the model. Now instead of doing this, what we could do is we could pass the data into the model directly and then carry out the resizing and rescaling in the model as a layer in the model. Now we've seen this already, but we'll just explain here again that doing this is great for deployment, because when you have to deploy this kind of system, you no longer want to resize it again. So here all you do now is just pass in this image, and then the model on its own, this the model which has been deployed, takes care of resizing and rescaling. Unlike in this kind of system where when you deploy this model, you have to do the resizing and rescaling on your own. So this means that if you deploy this model on some cloud solution and then you're calling it from a JavaScript client, for example, or say some Android client, then you would have to carry out this resizing and rescaling in JavaScript. Unlike here, where you just pass in the image and the model takes charge of resizing and rescaling. So that said, let's take this off, get back to our code. Here we're gonna run this simply, and then we start with building our model. Here we have this error, resize not defined. So simply we have keras layers here. So we should, just as we did here, do the resizing. So we have resizing. There we go. Run that cell again, and then get back to our. At this point, our data set is now ready for training. We just have to include this prefetching here for a more efficient usage of our data. We saw this kinds of prefetching, or we explained what prefetching was all about in some previous sessions. So here we have the prefetching. We're not going to include the batching because here already we've included the batch size previously. So in this data set loading right here, we specify the batch size. So our data is already batched. Now we have that. We run the cell for the training, and then we simply redo this for the validation. So this is our validation, data validation, and now we're ready for building our model. But before going on to build our model, we shall copy out this code here from the previous session and paste it out here. So we have this resize rescale layers, which we're going to include in the model. Now recall that we could do this resizing like we have our data set here. So supposing you have your data set, you could do the resizing and rescaling here. There's a rescaling and there's a resizing to the required size before passing this data into the model. So this could be done before passing into the model, such that you could train your model on this resized and rescaled data. Now another method will be to pass in your data here. So let's suppose that we have, let's take this off. We suppose that here we have, in this middle, we have the resizing and rescaling unit. So we resize and rescale before passing into the model. Now instead of doing this, what we could do is we could pass the data into the model directly and then carry out the resizing and rescaling in the model as a layer in the model. Now we've seen this already, but we'll just explain here again that doing this is great for deployment, because when you have to deploy this kind of system, you no longer want to resize it again. So here all you do now is just pass in this image, and then the model on its own, this the model which has been deployed, takes care of resizing and rescaling. Unlike in this kind of system where when you deploy this model, you have to do the resizing and rescaling on your own. So this means that if you deploy this model on some cloud solution and then you're calling it from a JavaScript client, for example, or say some Android client, then you would have to carry out this resizing and rescaling in JavaScript. Unlike here, where you just pass in the image and the model takes charge of resizing and rescaling. So that said, let's take this off, get back to our code. Here we're gonna run this simply, and then we start with building our model. Here we have this error, resizing not defined. So simply we have keras layers here. So we should, just as we did here, do the resizing. So we have resizing. There we go. Run that cell again, and we're now ready for modeling.